We'll start here with what design patterns are and what they're meant to address. First and foremost, design patterns are very general, very non-specific, yet reusable solutions or templates for how to solve specific design problems in software design. What may come to mind is the idea of a software component, but it turns out that's not exactly an appropriate metaphor for design patterns. Components, assemblies, things like this are elements of reuse, which is not necessarily a concern of design patterns. Design patterns are meant to address how specific classes, how specific code within a given code base relates to each other. Also, these recipes for solving problems are not around algorithms. So you're not going to see, for example, a quicksort pattern. Quicksort is not a pattern. It's a defined algorithm. A pattern would be more focused on how different class elements relate to each other when being designed to address a very common recurring problem type. And we give names to these patterns. Each pattern that we'll present in the library has a name, and we have these names so that we can talk about the patterns and we can all understand what it is each other means. Now, design patterns are focused squarely on the domain of application and system design. There are some higher level and some lower level patterns. So we do have patterns that address issues we find in enterprise architectures and service buses and very high level concepts like that. We also have patterns that function at a very, very low level and deal with things like how to create data structures that make themselves easily available for data binding. All sorts of patterns from low to high level and everything in between. And it's important to realize that these are abstractions on top of code. So we'll use terms when we talk about patterns like a view or a model. And when that class actually gets created inside of a software solution, there's nothing that says this class must be named model. So this is really an abstraction, a human idea that we lay in on top of our code. We can name our code files anything. They can have method names named as we wish, but the structure of the interfaces of our classes is what we're focused on when we talk about how those classes come together to form a design pattern. We'll see the word collaborators when we talk about the relationships between the classes involved in a particular pattern. Collaborators are classes that will typically interact with the pattern or might be in the pattern itself. And it's important for us to remember that patterns deal with problems that someone else has already encountered. Now, we all like to think we're special, but the real truth of the matter is that somewhere along the way, someone has probably seen this problem or a very similar problem to the one that you're focused on right now, particularly if we happen to be doing what most software developers in this world do, which is forms over data line of business type applications. If that's the kind of work that you happen to be involved in, design patterns will promise to really improve your life by giving you some templates to follow for things that occur on a daily basis in your development. Now, patterns, as we said, are not concerned with algorithms like quicksort, and they're not concerned with specific implementations. And that's very important to note because the intent of design patterns is to give us a starting point for solving a solution. A design pattern does not prescribe every single line of code that one must write in order to solve a particular problem because, yes, even though we see these recurring logical patterns in our code, situations really do differ.